Hello everybody, my name is Peter Wilson, and this is a video lecture to accompany section 12.3 in the textbook. And section 12.3 is on the two moons, Saturn's Titan and Triton, which is a moon of Neptune. And apart from the four large Galilean moons, these are the other two large moons in the outer part of the solar system. This is a picture that shows Saturn, which of course is the planet with the ring on around it. And then right above it is its moon Titan. And this is something you can see in the smallest of telescopes. So if you have a telescope kicking around the house someplace, if you can figure out how to point it at Saturn, you can see this in the eyepiece. Okay. So Titan is about the same size as Callisto and Ganymede and has about the same density. So you think it might be similar. But in some ways, Titan is more like Earth than a Jovian moon. It has a thick nitrogen atmosphere and has lakes and rivers, and hydrocarbon rain falls on its surface. While water can exist in solid, liquid, and gaseous forms simultaneously on Earth's surface, hydrocarbons can exist in the same three phases on the surface and in the atmosphere of Titan. So Titan's atmosphere is amazing. The density at the surface is 4 times greater than Earth's, and the surface atmospheric pressure is 1.6 times that of Earth, in spite of having a much smaller gravitational field. Although Titan's atmosphere is primarily nitrogen, it is rich in organic compounds such as ethane, methane, propane, and nitrogen compounds such as hydrogen cyanide and cyanoacetylene. There are also multiple layers of clouds and hydrocarbon haze in the atmosphere. So this is a diagram showing the structure of Titan's atmosphere. Methane, there's a sort of 2 tropospheres here. There's methane or ethane clouds, which can rain, and then there's a photochemical haze at about 300 kilometers up. And you can see the temperature is at all levels of Titan's atmosphere much colder than it would be on Earth. Okay. So everybody has a mystery. The mystery with Titan is why it's so different than any other known body in the solar system. And the biggest mystery in the solar system, of course, is why it has life in it. And life involves hydrocarbons, and Titan has hydrocarbons. Could Titan somehow be a link in the chain of events that brought life into the solar system? Titan is such an interesting body that the Cassini mission included a probe called Huygens that landed on Titan's surface. Huygens descended by parachute through the atmosphere, landed on Titan's surface on January 14th, 2005, the first and so far the only landing on a Jovian moon. Huygens appears to have landed on the shore of a hydrocarbon lake at a temperature of minus 179 degrees Celsius and continued to function for more than an hour after landing on the surface. And this shows the view that Huygens saw of the surface. The left image shows the views from the descent camera at different altitudes, and the right image shows the boulder-strewn surface. The boulders are not composed of rock. The boulders are composed of water ice, which on the surface of Titan is essentially a rock. Okay. And these are a couple of images of lakes as seen by Cassini. The image on the left, you can see the blue areas are lakes of hydrocarbons, and then in B you can see the sinuous erosion channels, which on Earth we would call rivers, and so that's the surface of Titan. Now we're going to talk about Triton, which is Neptune's moon. The 6 large moons in the outer part of the solar system, actually 7 if you count Earth's moon, So the 7 large moons in the solar system: Earth's moon, the 4 Galilean moons of Jupiter, then Saturn's moon, which is Titan, and then Neptune's moon, which is Triton. And Triton is unique in that it has a retrograde orbit and eventually is going to crash into the surface. So and it's the most distant of the large moons in the solar system. It's slightly larger and slightly more dense than Pluto, and it's the only known large moon in a retrograde orbit, which suggests that it may be in a gravitational capture. And it's possible that it was originally a Kuiper Belt object that escaped from the Kuiper Belt only to be captured by Neptune. So Titan's surface is composed of frozen water, nitrogen, methane, and carbon monoxide. It's highly reflective, which has the result when you have higher reflectivity, it lowers the temperature, and Titan's surface temperature is between 35 and 40 degrees Kelvin. 35 and 40 Kelvin, I should say. A small amount of nitrogen evaporates to form a very thin atmosphere, which supports some thin clouds. And the smooth surface suggests that occasionally the surface warms enough to melt, causing areas of resurfacing. The Voyager flyby of Triton occurred when the South Pole was tipped towards the Sun. This was enough to evaporate some of the nitrogen in Triton's southern polar cap. And Voyager imaged plumes of nitrogen gas rising 10 kilometers above Triton's surface. And that's what this picture here is showing. Or is it showing that? It's not showing that, actually. The pinkish area at the bottom is the southern polar cap. That's frozen nitrogen. That's down in this area. And it says and the slight heating effect is driving some of the material northward, where it's colder. Okay. This is a picture showing Triton's geysers, and you can see them by their shadows. They're long trains of dust, and pointing to the lower right. And so you can see this one here, for example, is the most obvious one, but all these little black smudges are nitrogen geysers. And that concludes the video lecture for section 12.3.